In this video, I want to compile the solution set for Chem 252 Analytical Chemistry IMSO 2018-2019 academic session. The first question says, what mass of KCl dissolved in 500 cm cubed solution is required to produce 0.07 mole per dm cube of solution? Now, these are the molar masses given to us. For us to solve, we know that the mass of potassium chloride is given as the molarity of the solution times the volume times the molar mass. Now, the molarity given to us in the question is 0.07 times the volume is 500 instead of in dm cubed. They gave it to us in cm cubed. So for us to put it in dm cubed, we need to divide it by 1000. Because 1 dm cubed equals 1000 cm cubed. So times the molar mass of potassium and chlorine combined is 74.602 gram per mole. So if we multiply and divide, we'll get 2.06, approximately 111 gram. This 1b says what are the necessary conditions for a substance to be called primary standard substance. The first condition is that it must react quantitatively with the substance to be determined by a definite predictable reaction. The second one is that the substance must be of high purity, that is 99.99% pure, or even better if possible. If impurities are present, the amount and nature of such impurities must be easily determined. The third condition is that it must neither be deliquescent nor efflorescent, and it must not be sensitive to any constituent of the atmosphere, so that throughout the weighing or shortage period, its composition remains constant. The next condition is that it must be of such high formula weight to make weighing errors negligible. And the last one is that it must be soluble in appropriable solvent. Number 1c says, if 0.100 molar of silver nitrate is being titrated against 25 cm cube of 0.100 molar of HCl, what is the concentration of chlorine ion in the solution when 25 cm cube of silver nitrate is added? Now, KSP of silver chloride is 1.0 times 10 raised to power minus 5 mole per dm cube at 25 degrees Celsius. Now, let's solve. For us to solve now, this pen is misbehaving. Okay, let's go. Before the addition of silver nitrate solution to the HCl solution, the concentration of chloride ion in the solution equals the concentration of HCl solution. That is 0.100 molar or mole per dm cube. Now, the pH of chlorine is equal to negative logarithm of the concentration of chlorine ion. And because of that, which is negative logarithm of 10 raised to power minus 1. And if we bring this 1 down, becomes plus. Log 10 base 10 is 1. So 1 times 1 is 1. So 1. After the addition of 25 cm cubed of silver nitrate, the solution will be saturated with respect to the silver ion and chloride ion, so that silver ion concentration in solution equals chloride ion concentration. But remember that KSP is equal to concentration of silver ion times concentration of chlorine ion, which is 1.0 times 10 raised to power minus 5 mole per dm cubed. And concentration of chlorine ion is equal to concentration of silver ion which is equal to KSP raised to the power 1/2 half. And because of that, if we square root this, we're going to have 3.16 times 10 raised to the power minus 3 mole per dm cube. Number 2a says, what conditions must a precipitation reaction meet to be satisfactory for analysis by titration? The answer is that the first one, the precipitates formed are practically insoluble. The second one there is that the precipitates reaction are instantaneous and rapid. The third point there is that the results of the titration are little, if at all, affected by such phenomena as cool precipitation or adsorption. The fourth point there is the equivalence point of the titration is easily determined. The next question says, explain how you can reduce or eliminate constant error which has been observed to affect the result of your chemical analysis. The answer is, one way of reducing constant error effect is to increase the sample size unit until the error is acceptable. The next question says, a chloride analysis of a rock sample found that the rock, which contains 98.6%, revealed a chloride content of 98.55% by titration with silver nitrate solution. Calculate the relative error in parts per 100 and parts per 1,000. So for us to solve, relative error is given as the measured value, we use this, minus the true value over the true value times 100. Now, which gives us 98.55 minus 98.6 over 98.6 times 100. This is in parts per 100. So what we'll get is that the relative error is minus 0.05%. Now, it says we should also solve it in parts per 1,000. Parts per 1,000 means we multiply by 1,000. So relative error is 98.55 minus 98.6 over 98.6 times 1,000. So that what we're going to get is minus 0.5 in parts per 1,000. The next question says, in an attempt to calibrate 10 cm3 measuring cylinder, a student recorded the following readings: 9.987 cm3, 9.9997 cm3, and 9.986 cm3. Calculate the mean deviation, relative mean deviation, variance, standard deviation. So for us to solve, mean is given as the summation of individual values over the number of values. So that we'll have 9.987 plus 9.9997 plus 9.986 over, there are 3 in numbers, so we say over 3. So what we have is 9.9909 cm3. That's the mean. Another word for mean is average. So for us to, the second one is for us to get mean deviation. Mean deviation is equal to the value minus the mean. So we write out the individual values, we minus them, we minus the mean from them, and then we get the deviation. So I'm going to pause the video so I can conserve time. So these are the individual values. The individual value minus the mean gives us this. Individual value minus the mean gives us this. Individual value minus the mean gives us this. So the deviation, mean deviation, is summation of this. So if we sum all of that, we get 0. The third one is relative mean deviation. And relative mean deviation is given as if we have a summation of d divided by n times 1000. So what we have is 0 over 3 times 1000, which is still 0. The last one is variance. And variance, okay, second to the last, variance, let's use V to denote it, is given as summation individual numbers starting from 1 to n. In this question, the n is 3, into individual values squared minus summation of the individual value squared divided by number all over n minus 1. So we need to prepare a table for this so we can get the individual values, their squares. So these are the individual values, these are their squares. So if we add all of them together, this is what we get. So our variance is now summation of x squared, which is this. So we have 229.54544 minus, you need to remember when preparing the table that mutilation is not allowed. What we mean by that is that you don't write 2 and now turn it to, let's say, 6. This is not allowed in the table. The table will need to be neat. So minus the squared, which is 29.9727. That is if you add this side. So the two x squares are not the same. The first one is summation of x squared. That's square them first, then sum. The second x squared is first of all add only it. So adding of x. So we have over 3, all over 3 minus 1. So that variance we have 219.4635 over 2. And variance is 109.7318. The last one says the standard deviation. So for us to get the standard deviation is given as square root of variance, which is square root of 109.7318, which will give you 10.4753. The next question says, what determines the amount of materials required for analysis? The answer for that is that the first one is the capacity of the apparatus available. The second one is the economy of materials and time. The third one is the number of measurements to be made. The next question says, state the information that must be known in order to estimate the material to be weighed. Now, the answer to that is that the first one is the number of determinations to be run with the solution. The second one is the stoichiometric relationship in the reaction. The third one is the capacity of the flask in which the solution is to be contained. The fourth one is the molar mass of the substance. The next question says, discuss the method error and how it can be discovered and corrected in a chemical analysis. Now, the answer to that is that method errors are errors that arise from non-ideal chemical or physical behavior of reagents or reactions. Non-ideality may arise from slowness or some reactions or incompleteness of others, instability of some species, non-specificity of most laboratory reagents, and possible occurrence of interfering side reactions. What we mean by that is when the indicators used in titration reacts with one or the other of the reagents. Now, these errors are not easily discovered. However, there are a number of steps that can be used to recognize and possibly correct them. The first one is analysis of standard samples. The second one is independent analysis That is a method that differs from the one that you are understudying. The third one is blank determination. A blank determination, a blank actually contains every other component of the sample except the species being determined. The next question says, what is gravimetry? Now the answer to that is that gravimetry is the process of estimation of the amount of an element in a sample by isolating it or a definite compound of it in as pure form as possible from a weighed portion of the substance being analyzed and weighing the isolated form. The next question says, what volume of 0.250 molar solution must be diluted to obtain a 500 ml of 0.100 solution of potassium heptaosodichromate 7 solution? Now, the formula we can use for this is M1 V1 is equal to M2 V2. Now, from the question, our M1 is 0.250. Now, our M2 is 0.100. Then our V1 is what we don't know, and our V2 is 500 ml. Now, from here we can make V1 subject of the formula. Our V1 becomes equal to M2 V2 over M1, which is 0.100 times 500 over 0.250, and if we calculate that, the V1 is 200 ml. The next question says, how many milliliters of concentrated sulfuric acid 94.0% gram per 100 gram solution 1.83 gram per dm cubed are required to prepare 1 liter of 0.100 molar solution? Now, the first thing is to multiply the mass concentration, which is, for us to get the actual mass, 183 here times the percentage 94 over 100, which gives us 1.72 grams. Now we know that mass in cm cubed times 1000 cm cubed in dm cubed per dm cubed. Now cm cubed, we cancel out cm cubed, therefore what we have is mass. I need to turn. We now have that for the mass we have 1.72 times, we have 1000 left, 1000. What we have is 1720 gram per dm cubed. Now remember that molarity is given as mass in dm cubed per dm cubed over molar mass, which is this 1720 over the molar mass is 98 gram per mole. So if we divide that in the calculator, we're going to get 17.55 molar. Now remember that the relationship that volume has with molarity is M1 V1 equals M2 V2. Our M1 is this, and our V1 is what we're looking for. Our M2 is 0.100, if I'm correct. I need to check. Yeah, 0.100 molar, and our V2 has to be 1000. So we're going to, if we make V1 subject of the formula, it becomes M2 V2 over M1 over M1, and if we fix that, it becomes 0.1 times 1000 over 1755. So we'll get 5.7 mil. The next question says, analytical chemistry seeks to provide two fundamental answers to substances. These are, the answer is qualitative and quantitative answers. Qualitative is talking about what is present, the quality, what is present, while quantitative is talking about how much is present. The next question says, a microbiology student whose project involved analysis of sugar in a patient was faced with methods. What will she consider in order to make a choice for his analysis? So since we say his, let's use he. So the answer is that he's going to consider accuracy, he's going to consider precision, he's going to consider sensitivity, he's going to consider specificity, he's going to consider selectivity. So he's going to consider accuracy, he's going to consider precision, he's going to consider sensitivity, he's going to consider specificity and selectivity. The next question says, a 0.8574 gram sample of limestone was dissolved in HCl and diluted to 100 cm cubed. A 10 cm cube of alicate of the solution required 30 cm cubed of 0.02027 molar EDTA for titration. Calculate the percentage of calcium carbonate in the limestone sample. The formula we're going to use for this is that 10 times the molarity times the sample volume all over the aliquots times the volume times the sample weight. Since it's in percentage, we say times 100 over 1. So the molarity is 0.02 whatever. The sample volume is 30 cm cubed, and the aliquot volume is 10 cm cubed, and the sample weight is 0.8 grams. So what we have is 10 times 0.02027 times 30 over 10 times 0.8574 times 100 over 1. So the up, what we'll get is 60.608.1 over 8.574, which is 70.9%. The next question says, what is the pOH of a 2.27 times 10 raised to the power minus 2 solution? pOH is what we're asked for. We know that pH is equal to negative logarithm of the concentration of hydrogen ion. Now, pH is equal to negative logarithm of the concentration is 2.27 times 10 raised to the power minus 2. Now, if we press the logarithm of that, we have 1.64. Now, we remember that pH plus pOH is equal to 14. So what it means is that 14 minus pH, which is 1.64, gives us pOH. So what we now have is that the pOH is equal to 12.36. The next question says, discuss the three types of factors causing deviation from D'Alembert's law. Giving example of in each case. Now, the first one is the chemical factor. And for the chemical factor, we have change in concentration under chemical factor. Now, when an absorbing species is in equilibrium with another species of different absorption characteristics, and the position of the equilibrium depends on concentration. What we mean by that is, for example, In aqueous solution of potassium dichromate 6, the dichromate 6 ion is in equilibrium with dichromate 6 due to the reaction. What we mean by that is CrO2O7 2 minus plus H2O. The forward reaction is slower than the backward reaction. So we have this. Under chemical factors, we have another factor is a change in pH of the solution. In strongly acid solution, essentially all the chromium 6 is in the form of this CrO2O7 is in the form of ion, and Beer law holds. But in strongly alkaline solution, Cr6 chromium 6 is present as CrO42 minus, and Beer's law is also obeyed. Another factor is instrumental factor, something like bandwidth of radiation. Now, Beer's law strictly applies to monochromatic radiation and is approximate for narrow bandwidth radiation. As the bandwidth increases, absorptivity increases also. Under instrumental factors, we have stray radiation also. Stray light is the radiation of different wavelength from that predetermined by the monochromatic setting, which may reach the detector or readout to the instrument. That's readout of that instrument. So another factor is physical factor, arising from non-reproducible reflections of cells, mirrors, lenses, changes in cell length, and scattering of light by suspended particles. The next question says, what is the principle of separation? Now the answer is that it is the distribution of components of a mixture between two immiscible phases. Each component is distributed using partition law, now which is amount in phase 1 over amount in phase 2 is equal to K. K is known as distribution ratio or partition ratio. The next question says, what is a sample? A sample is a portion of material or replicate result selected from a larger quantity of material or experiment performed. The next question says, discuss the characteristics of titration reactions. Now the first one is, the reaction must be stoichiometric. What we mean by that is that there must be a well-defined and known reaction between the analyte and the titrand. The ratio of the reacting substances must be known. Example is, if we have this plus, let's use NaOH, and we'll have NaC2H3O2 plus H2O. Okay, this is an example, a balanced chemical reaction. The second one is that the reaction should be rapid. Organic reactions are slow and thus less useful in titrations. The third one is, there should be no side reactions and the reaction should be specific. The fourth one is, the reaction should be quantitative, that is, it proceeds with 100% efficiency. The fifth one is, there must be a means of detecting endpoint. So these are the characteristics of the titration reactions. Do well to subscribe to my channel if you have not subscribed yet. Share the videos. Thank you.